Assalamualaikum, my name is Mohamed My number matric is AA212360. So now I would like to present about the introduction of this project. The first one is about what is stormwater. Stormwater is referred to the water from precipitation like rain or snow that collects on the earth's surface. It often pick up contaminants such as oil, chemical and pathogen, which can flow untreated into nearby water bodies unless managed. The second one is urban impact of runoff. Impermeable surface in cities like road and rooftop prevent water from soaking into the ground, increase runoff. This contribute to flooding, sewage, overflow and pollution. The last one is stormwater management. Effective management includes stormwater, sewage, green infrastructure and low impact development to reduce runoff and mitigate its negative effect. The next is about background of study area. Actually, the study area has been given in this project, so we like to highlight the certain important point. The first one is about open channel flow, movement of fluid over an exposed surface with atmospheric pressure, found in lakes, river stream, flumes, ditches and seaways. Flow freely under gravity unlike pipe flow which occur under pressure. The second is about flow classification. Steady flow, velocity remains constant over time at a given point. Unsteady flow, velocity varies over time. Uniform flow, velocity is constant at every location along the channel. And non-uniform flow, velocity changes along the channel. The last point is about drainage system. Micro drainage, network of small drainage for localized areas like home or apartment. Drains connect to major drainage system or natural waterway. Main drains, interceptor drains, handle water for large city area, and the last one is channel often have trapezoidal cross-sectional. Okay, next we go through into the objective of this project. The first one is to recommend a sustainable drainage system that can effectively lessen the heavy flow. Second, to ascertain the proper drainage system and type for Taman Universiti Parit Raja. And the last one is to examine the water flow across the drain as part of Taman Universiti Parit Raja proposed drainage system. Okay, the last one is about problem statement. The first problem statement, the drainage system was improperly designed to prevent several rains and flood from overflowing the road. And second, when construction the stormwater drainage system, the flow channel size must be carefully considered since it is inappropriate for that area. And the last one is the increasing amount of rain is too much for the drainage system to handle.
Now I will explain about the methodology for this project. To evaluate the MS4 system for flood mitigation, hydraulic models and flow simulators, we used to simulate various rainstorm scenarios. Historical rainfall data and field measurement like flow rates and drainage characteristics were used as inputs. This simulation tests the system performance under realistic conditions by assessing its ability to manage peak flows, retain stormwater, and prevent overflows. Statistical analysis compared rainfall intensity with water level to measure efficiency. Although the model did not account for extreme climate events, multiple simulation, data validation, and sensitivity testing ensured reliable results. This will approach provide valuable insight and guidance for improving the MS4 system.
So, I will go through to the first question. State the name of stormwater drainage design manual required to be used authority for drainage design in Malaysia. The Urban Stormwater Management Manual for Malaysia, or MASMA, is the official standard that must be followed when designing stormwater drainage in Malaysia. MASMA also provides specific requirements for drainage system sizing and architecture, as well as advice for calculating stormwater runoff and determining acceptable pipe sizes. The guidebook emphasizes flood control and mitigation by detailing measures like flood detention ponds, retention basins, and other infrastructure to reduce peak runoff during storms. It also provides guidelines for reducing pollution in stormwater runoff, a critical concern in urban areas where runoff can carry contaminants such as oil, heavy metals, and debris. The next question is why flash flood occurs at the location. The first reason is insufficient drainage capacity. Flash floods often occur in areas with limited drainage capacity, particularly near major roads where impervious surfaces generate rapid runoff, and overloaded or poorly maintained drainage systems, exacerbated by blockages from debris, fail to discharge rainwater, leading to pooling, safety risks, and disruption to transportation and nearby properties. The next reason is urbanization and impermeable surfaces. Urbanization significantly contributes to flash floods as the replacement of natural landscapes with impervious surfaces accelerates runoff, overwhelms drainage system, and disrupt established water absorption and drainage pattern, particularly in rapidly growing areas. The next one is low-lying topography. Low-lying topography contributes significantly to flash flooding by naturally collecting runoff during heavy rainfall, a risk exacerbated in urbanized areas with impermeable surfaces and inadequate drainage, where water flows rapidly into depressions, often aligning with natural floodplains or former waterways, resulting in heightened vulnerability to pooling and infrastructure damage.
Hello, my name is Zaki Irfan, and now I will be explaining about Chapter 3, which is our proposed flood mitigation method. We chose the Municipal Separate Storm Sewer System, short form as MS4. So, based on our research, we have found three methods to mitigate the flood. And the first method was to make or create an inside storage where we can collect and save rainwater, which will be supplied to other areas. And then the second method is to improvise the drainage system by increasing the width and adding more height. And the last method is the Municipal Separate Storm Sewer System, MS4, which I will describe as a system where we will collect rainwater and then we will separate into two types, where we have sanitary sewer and storm drain. And then we will the water which is less chemical, is not harmful, will be bring to the natural waterway such as the river or the ocean, whereas water that contains harmful bacteria will be carried to the treatment plant. And from our analysis and our site visit, we have decided that the MS4 is probably the best method based on the location, because the location is located at Taman U, and around the area it is very crowded. It is full of people, and there is not enough storage. There is not enough area to create inside storage such as a man-made river nearby the area, because the nearby the drainage system there are the main road, and on the other side there's like apartments, and nearby there are also shops for the villagers to stay. We also reject the idea where improving the drainage system, because it is not a good idea, like I explained earlier, where the nearby the drainage system is the main road for Parit Raja Road, and then on the other side is full of shops, and making the drainage system larger is probably the worst idea compared to these other three. And based on our understanding, we think that municipal separate storm sewer system MS4 is the best method to control flood in the area. And this method really focus on the separation of stormwater runoff from sanitary sewage, and it consists of different types of structures such as pipes, culverts, detention bases. We also have inlets to collect the rainwater. However, the inlets they will reduce the amount of leaves inside the storm drain. And now I will be explaining how the municipal separate storm sewer system MS4 works and function. So the first step is by collecting storm water, and during raining, storm water is collected from the surface such as road, rooftops and parking lots, entering the MS4 network through gated inlets. After that is the stormwater transportation. We will flow the stormwater in underground pipes and open channels that guide it into designated outfalls or treatment facilities. And last but not least is the final distribution. For stormwater containing dangerous chemicals, the stormwater is directed to treatment facilities. Meanwhile, for rainwater that are free from harmless bacteria, we will flow the rainwater directly into natural bodies such as the river or the ocean. So now I will explain how the MS4 controls and reduces flood possibilities. It is effective at managing stormwater volumes and direct them away from populated areas. It eliminates the risk of system overloading, which can lead to sewage backups and localized flooding. It is also significantly will reduce the peak flow rates, minimizing the strain on natural watercourses and urban drainage systems. And the MS4 is equipped with detention basins and storage facilities that temporarily hold excess runoff. So overall, the MS4 is very good at controlling and reducing flood possibilities. Next, I will describe the positive outcomes of the MS4 system. Firstly, obviously it prevents flooding because the MS4 effectively channels stormwater away from urban areas by managing large volumes of rainwater even during intense tropical storms. So even when it's raining heavily, the water will be flowed underground and distributed into specific locations. Next, it protects water quality. By separating stormwater from sewage, the MS4 prevents untreated wastewater from overflowing into water bodies, overall improving water quality. Last but not least, the MS4 system is nature friendly. The MS4 system separates stormwater from sewage, ensuring that untreated wastewater does not mix with rainwater.
Lastly, I will continue about the conclusion for this project. This project demonstrates that the MS4 system is an effective solution for managing urban flooding. Through simulation and analysis, the system was shown to reduce peak water flow, retain stormwater, and prevent overflows during typical rainfall event. its cost effectiveness and adaptability make it a practical choice for urban stormwater management. However, the study identified limitations such as the model's inability to predict performance under extreme weather conditions or climate change impact. This highlights the need for future research and system improvement to enhance resilience. By ensuring reliability through data validation and sensitivity testing, the study provides valuable insight into the MS4 system strength and area for enhancement. Overall, the project confirms the importance of integrating MS4 system into urban infrastructure to mitigate flooding and improve resilience against future challenges. That's all. Thank you.